We kept the secret from Annika. She just thought we were coming to the aquarium. All these people are there, and I told Annie there's gonna be some cameras.
She really inspires me a lot. I love her movie. They told me I was gonna feed her fish, so when they opened the cooler and I saw this, I'm like, this is not fish. What am I looking at? This is not fish.
When she opened up that box and her arm was in that, I think that's when she finally got it, that this is mine.
We're developing a new technology for designers who use CAD/CAM computers. This is so that the designer can directly make a prototype from the image that he has on the screen of his terminal. We call this technology stereolithography, or three-dimensional printing.
This process of stereolithography that Chuck Hull would patent in 1986 is an additive manufacturing process, which means that one layer at a time would be printed until the design was completed. The plasticky gloop material out of the printer is photopolymers, and the benefit of these polymers was that they remain liquid until hit with an ultraviolet light, which then solidifies it, turning it into a solid piece of plastic.
Prototyping plastics was a really big issue at the time. It took lots of weeks, even months, between when an engineer had a design and then had the first prototype. So it was a big problem that I tried to solve. So that got me into experimenting and trying to figure out how to do 3D printing with these kinds of materials. When I invented 3D printing, I guess over 30 years ago now, I had lots of things in mind for it, but I just couldn't imagine all of the things that happened in almost an industrial revolution.
Albert had joined the group probably a year before he was asked to do an arm for Alex. In that year's time, there was more people got excited about the 3D printing of hands. And so when Albert came in, the first design that he had that he thought was the only design that was out there was this. And when he got me involved with this, I had to research it out. And what I found next was this arm here. And it became more structurally sound as time went on. And then more and more people, engineers, people that became aware of 3D printing, got involved. More people started putting designs out there. I came across this design right here that Mr. Woods had came up with, and it's so lifelike. I wanted to make sure that I gave Albert the best that the shop could provide. I knew that this hand was the best to work from. I showed the guys the video how Mr. Woods had this hand that he came up with and how it worked. I printed the hand. Then the next day when Albert came in, I showed him what it looked like. He was amazed. And all we had to do was print the fingers and the cartilages. The kids had something to work off of. After that, they built the forearm, which became the electronic housing. They built prototypes, gathered all the parts and put them in there. That's kind of how it got started.
Limitless Solutions is a nonprofit organization created by some students on the UCF campus. They're devoted to using 3D printing technology to help children around the world by providing a low-cost prosthetic arm at no cost to the family. They designed the arms using a 3D printing technology in the engineering building on campus. The students are fortunate to have access to different manufacturing labs, equipment, and a top-of-the-line 3D printer to express their ideas and work on different projects. This opportunity provided by UCF allowed a few innovative students to create prosthetic arms that make all the difference in the children's lives. Through donations and support from the community, Limitless Solutions is able to make prosthetic arms and give them for free to kids like Annie and Wyatt.
Working with Limitless has been one of the most moving and challenging jobs like I could have ever imagined. And coming from an aerospace background, that had been my dream my whole life, was to be able to build space planes. And since getting involved here and seeing this nonprofit be able to really take off, it has been so moving because you're taking what you've learned in a classroom And yet when you're applying it in real life with a child in need, and you see their face and you see how it affects their family, and just watching Annie cry as she put on the arm for the first time, and she hugged me and I hugged her back, and that was just the kind of the pinnacle of what we've done here. And it's such a unique thing to take and bring that emotion into what's normally just with machines. And so for me, that's been perhaps my favorite part of this.
So as you can see, some of these hands have holes in them, and what you do is you're supposed to wire them up, and eventually they would look like this. So as you can see, they all bend. After all of these fingers are wired in and assembled, we have our painter come in and paint what it is that the child wants. We have frozen styled arms. These are sleeves that have assembled in pieces. So we have the arms, and you just slip it in. And then once they're fitted, we have sensors here that are placed on the forearm of the child. And all they do is flex. So they're placed here, here, and on their elbow. It all depends on the length of their arm as well. We had one child that didn't need a complete arm, he just needed specific fingers, so what ended up happening was it was just the hand that was printed. What's inside the arm are circuit boards along with batteries. And right now we're working on having the battery be a lot thinner, kind of like what you see in your cell phone. This here is a prototype of their elbow. It's not yet ready, but this is what it would look like. It would have more comfortable bend as opposed to this, where it's pretty rigid. And so we have our team working on that. This is a complete arm of what it would look like. And so you can see here, we would have the battery fitted underneath. So everything's more compact, because sometimes when everything is fitted in too tightly, it won't work. So we're working on having the space adjusted. This is a leg, Exoskeleton Adaptation. So he has something similar to this, but this would be a lot more affordable for him. This is for Annie. She likes to play guitar, so we made an arm/hand where she can fit in a pick and easily strum. So this is all just prototypes for now. Like I said, once they're printed out, sanded, as you can see there's ridges. We have to sand it out, apply a gloss, and then paint over it. We have UCF students coming together to learn how to assemble, wire, CAD for those that are interested.
Working on a 12 Arms for Christmas project with the idea of delivering 12 arms for 12 different children located all around the US for this Christmas. So starting from fundraising and planning till right now, what we're doing is actually production. So making sure that we have all the kits, first of all, and all the information and material that we need. And then we divided everything into different teams so that each of the teams develop an arm. So we're able to actually deliver 12 in just a few months, five months actually, that we have to deliver these 12 arms. Whenever anyone reaches out to us requesting an arm, the very first step for them is to contact us via email, or maybe they get to us through social media, mostly Facebook or Twitter sometimes. After we receive that first email, communication starts with them, so we kind of request some pictures so we can actually see what's going on or the condition of the child. Then we request them to fill out a measurement form that we have, standard for everyone, so that by the time we jump into designing, we know exactly what needs to be designed and what not for the child's convenience. Some of our kids we've worked with locally, they've lived here in the area, so whenever we need to work with them and meet with them to check some details of the arm, we've had the chance to meet with them. However, some of the projects that we're working on are all over the US, even out of the US. So all of the communication has been through email. Every now and then, it's getting harder via email. We do jump into Skype and video calls for them to see us and making it a little bit easier. After we get all the material, pictures, measurements, everything that we need, then the design process starts. And from there, that's on us, on our designers, doing all the hard work, as I call it. So they create different prototypes for us to test the material, then the scale that we use for printing or for even scaling the arm, the computer. Once we have what we call a prototype, if possible, we meet with the parents and the child to test it, and from there the process goes on. If we need to redesign, reprint, modify something, we go ahead and do that until we get our next prototype, and that's how it works, the process for finally getting a limitless arm.
Right now, we're working on advancing the next generation of Limitless's arms, and that includes both waterproofing and getting more professionally made electronics, and where we've been handcrafting every board before, now we're working with some industry partners to be able to make things on kind of the next level. And so while we're still not able to plunge them into a pool yet, we're pretty excited because the future's pretty bright for the technology.
There are many emotions that we go through when we work in these type of projects, and that's something that you won't expect, or at least I wouldn't, and that's something that's not included in the job description whenever you first join.
And to hear that they can finally hold their parents' hand when they're crossing the street, or give hugs, fist pump, all those little things that we take for granted. So yeah, it gets really emotional, and you become attached to the children because you watch them grow, you watch their self-expression become open, and when they come and meet us, they're just so excited and very comfortable around everyone. So you see that confidence change.
But something so related to science and engineering turns out to be about giving back and improving someone's lives. I never expected engineering to be able to touch someone or touch me that way, and that I love from this project. I've been involved with other different type of jobs and projects, but never to this kind of level.
Thank you, guys. My new robotic arm! Wow!
How do you like it?
It's pretty awesome.
So you got to see a little bit of Wyatt, the Blue Man kid. And so when Wyatt contacted us, his family emailed us, we found out that he actually battles autism, and he is a true fighter in everything he does. And so when he was young, up until about age 6 or 7, he was completely nonverbal. He's now age 12 since getting the arm. And now with that incredible confidence he's gained, he now wants to become a counselor at the same nonverbal camp he used to go to. And his answer was he wants to help inspire kids to know that they're not alone and that they can do it too. And so we are thrilled to watch him grow and excel, and he wants to come to UCF and do film and study how to make videos. And so we are so proud of him and seeing his growth. And for us, that is the biggest deal, is to see how the arm not only affects their functionality in day-to-day life, but how that confidence really inspires them to keep dreaming. In 2016, Limitless's goal is to go global. And so we're looking for partners in our community and in industry and around the world to help us take these arms, send the files, have other groups be able to print them, or help us with the shipping, so that these arms can help any child in need anywhere in the world. And our view is that children are all created equal, and they're all equally deserving of getting an arm or a hand, a helping hand. And so that is our goal in 2016, is really push that. We started with our Help Syria campaign for children who have been displaced from their home country because of the civil war there, and have fled but have also lost limbs in the process. And that's our goal, is really how do we find those who are in the most need, who can we help the most effectively, and then bring the solution to the ground. Our other goal is to really be able to help veterans and adults in need who are coming back, especially from armed service, and we know that they deserve the best. And right now that does take time with the VA to be able to get them the device, and we're hoping to come alongside with them and work as a temporary device that can help them in that interim, so that they can hold their child's hand again and be able to go through normal life with just a little bit more simplicity. And as they get their final medical solution, then they'll be good to go.